Okay, I'm going to be explaining the law and more in depth from what you couldn't have seen in the experiment. So basically how this formula is made is a mix of like the Avogadro's law, Boyle's law, and Charles' law. And all three of those were like demonstrated. For our demonstration, first we blew up the balloon. So that basically shows how it shows the relationship between volume and the amount of gas or whatever you're doing. So that would be like volume is equal to the number of whatever you have. Because in a balloon, you fill it up with air and it expands, obviously. Its volume gets bigger once you add more air to it. That's Avogadro's law, by the way. And then for the next part, it's, I'm gonna explain Boyle's law, and that is the part with the temperature of the balloon, and basically the volume is equal to the inverse of the pressure. So yeah, when volume increases, pressure decreases. That's why it's the inverse, because the inverse is opposite. So that's why there's like the pressure in the balloon is much higher than the pressure around us, and that's why the air wants to escape. Because if you don't change the amount of matter, if you don't change the N or the T and they stay constant, and you don't change the amount or the temperature, and you just increase the volume or decrease the volume, that's going to affect the pressure in the opposite way, in its inverse. So if you were to increase the volume, the pressure would increase. Or no, the pressure would decrease because there's more space for the same amount of stuff to spread out, I guess. And then if you were to decrease the volume, the pressure would increase because it's all getting compact into a smaller amount of volume with this still constant N and constant T. And that's Boyle's law. Then for the third part is Charles' law, which states that volume is like proportional or whatever to temperature. That's a really strange looking T, but basically that just means that this would explain why the air coming out of the balloon is much cooler than the air that we feel around us, because like I had stated in Boyle's law, this one, when there's more volume, when there's less volume, there's higher pressure. So in a balloon, the pressure is really high, and when the pressure is high, the volume is low. And when the volume is low, the temperature is low, because these two go hand in hand with each other. So that's how our balloon experiment would prove that. Yeah, and so basically the ideal law is just putting all of these into a formula right there. Because if you were to put all of these together, if you look at it from like a more math standpoint, I guess, basically you could say that, let me move this a little bit. You could say that the volume would equal the amount, because as it showed up here, and then also temperature, as in over here, all divided by pressure, as you see here. And that's the beginning of the formula, but if you were to do like basic algebra and just multiply P times both sides, you know, P would cancel. And then you would be left with the formula up here because you would move P to the other side.